to find the complete integral of all these partial differential equations. Because we need the format in f p q equal to 0, the equation in p and q only, and in this case we put p equal to the constant a, so that we can get the value of q in terms of a. So first one is z square equal to pqxy. We can write this equation into the format. If I write this equation as pqx divided by z, y divided by z to be equal to 1, then we can have x divided by z with p and y divided by z with q equals to 1. And we know that what is p? It is the partial derivative of z with respect to x. And q is the partial derivative of z with respect to y. That is why I have taken x by z with p, because p is partial derivative of z with respect to x and q is partial derivative of z with respect to y equal to 1. So as what we have done in the previous examples, just take u to be equal to log of x, and we take v to be equal to log of y, and w is equal to log of z. I have mentioned the remarks where we have to take u, v and w and in what format. Please check those remarks from the previous contents. So applying all these over here, what we get? We have the derivative of z with respect to x to be equal to, we have partial derivative of z with respect to w, then partial derivative of w with respect to u, then partial derivative of u with respect to x. So this is equal to, when derivating z with respect to w, what we get? From here we have e the power w to be equal to z. If I derivate z with respect to w, I get e the power w, right? That is, I'm getting again z. So writing here z, okay. Derivating w with respect to u, we cannot do that. So I'm taking this to be as p. And derivating u with respect to x, we have 1 divided by x. And z by x into p. So putting the value of this over here. Similarly, we can have partial derivative of z with respect to y to be equal to partial derivative of z with respect to w, partial derivative of w with respect to v, and partial derivative of v with respect to y. So derivating z with respect to w, we get e the power w is the same. So it is z. We cannot derivate this, so we take this as q, and this will be derivating v with respect to y, we get 1 divided by y. So this is z divided by y into q. So let's put this value also over here. So we get x divided by z into, or z by x into p, then multiplied with y by z, del z by del y, which is z by y into q. So this is y by z, that is z by y into capital Q, and this is equal to 1, where we have taken p to be equal to del w by del u and q to be equal to del w by del v. So cancelling this, we get pq to be equal to 1. So now we have got our equation in the format fpq to be equal to 0, and for this we take p to be equal to a. So when taking p to be equal to a over here, we get aq is equal to 1, that is the value of q is 1 divided by a. So we have got both the values of p and q, and now we need to use dz to be equal to p dx plus q dy, because we have involved w over here. So instead of dz, we must write here dw, and it is p du plus q dv, and write here capital P. Okay, so dw is equal to, what is capital P? It is a du plus capital Q is 1 divided by a dv. So when integrating both the sides, we are getting w to be equal to au plus 1 divided by av plus the constant, let's say, b. And now putting all the values of u and v, w back. So what is w? We have w to be log z. So writing here log of z equals to a into u. A into log of u is log of x. Then plus 1 by a into v. That is log of y plus the constant b. So we are getting z to be equal to x power a multiplied with y power 1 divided by a. Let me take this to be as the constant log of b because of logs. Let me take this log of b, the constant. So it is also multiplied with this. So this is the required complete integral. Next, solving this. Let's take this z to the denominator of this. So we have p square x square divided by z plus q square y square divided by z to be equal to 1. Can I write like this? Yes, definitely. So here we can also write this as px divided by square root z whole square plus qy divided by square root z whole square equal to 1. That's okay? Alright. Next, what is p? It is partial derivative of z with respect to x. What is q? It is partial derivative of z with respect to y. Let's use this. So partial derivative of z with respect to x, and here x divided by root z whole square, and plus partial derivative of z with respect to y, and here y divided by square root z whole square equal to 1. Now here also again we need to take u to be equal to log of x, v to be equal to log of y, and w to be equal to, we have square root z over here. In the previous example we have z, so we have taken w to be log of z, but now here we have square root of z. So let's take w to be equal to not log of square root z, but let's take this as 2 times square root z. Let's see what happens. So what is del z by del x? It is del z by del w by del u, and then del u by del x. Let me write this as squaring both the sides. We have w square divided by 4 equal to z. Derivating z with respect to w, what we get? It is 2w divided by 4, that is w divided by 2, right? Taking this as to be capital P, we cannot find this, and derivating u with respect to x, we have 1 divided by x. Similarly, del z by del y, this will be equal to w divided by 2 into q into 1 divided by y, right? Let's put these two values in this equation, cancelling this. And also, what is w divided by 2 root z? W divided by 2 root z is 1. So we have this value to be equal to 1. So we have now the equation to be p square plus q square equal to 1. That's it. Okay. What happens if I take w to be equal to log of z? To clear the doubt, what will happen if we take, w to be equal to log of square root z? Then we get the value of z to be e the power w equal to square root z, that is z equal to e the power w whole square. We will get this, right? And when putting this value, if I derivate z with respect to w, I will be having 2 e the power w into 1, and that will be 2. What is e power w in terms of z? Square root of z, right? So we have here 2 square root z into p into 1 by x. Similarly, we have here 2 root z into q into 1 divided by y. Do we get the equation in the format fpq? Let's check that. So cancelling this, we have also cancelled this, cancelling this. So here we are getting 4p square plus 4q square. That means we have p square plus q square to be equal to 1 divided by 4. You can take that value. You can take w to be equal to log of root z. You can also take this, right? Your equation should be in the format fpq. If it is coming in this format, you can take the desired value w equal to log root z. You can also try w to be equal to log of z as before, but because I'm having square root z over here and I need to cancel that, so that is why it's better to take log of root z. Or you can also take, like I have done in this example, 2 root z. Whatever value you are comfortable with, you can take that. You have to guess from your side. The values of u to be log of x, v to be log of y, and we have taken w to be equal to 2 root z for this equation. So now take p to be equal to constant, and we have a square plus q square to be equal to 1, and q square is equal to 1 minus a square. Let's use again. So from here we get q to be equal to the square root of 1 minus a square. And now we are going to apply dw to be equal to capital P du plus capital Q dv, right? Okay, what is capital P? It is a, the constant, plus q is the square root of 1 minus a square dv. And when integrating, we are getting w to be equal to au plus the square root of 1 minus a square v. And now putting back all the values of w, u and v over here. What is w? It is 2 square root z. So writing here 2 square root z equals to a into u is log x plus the square root of 1 minus a square v is log of y. Sorry, here also we have the constant p. Let's write this as b, the constant, plus b. This is the required complete integral. So this is the required complete integral of the given equation. We have p square x square plus px equal to q. That is, we are only having one variable with p and q, that is x. There is no z in this equation. There is no z. There is no y. So what we have to do, just take your u to be equal to log of x, that's it. And we know that p is del z by del x and q is del z by del y. So from this equation we get del z by del x whole square x square plus del z by del x into x equals to q. What is del z by del x? We need to calculate this. It is del z by del u into del u by del x. We cannot derivate this. Take this as your capital P, and del u by del x is from here 1 by x. This is nothing but your small p. So we can have capital P to be equal to, this implies small p into x. So let's use the value of p over here. If capital P is small p into x, what is p? It is capital P by x. So capital P by x square into x square. It's square into x square plus px capital P by x into x, then equal to q. Equal to q. Cancelling this, and we get p square plus p equal to q. Taking capital P to be a over here, we get a square plus a is equal to q. We are having the value of p, we are having the value of q. Now we need to apply. Okay, now here dz to be equal to p du plus q dv, but there is no q, no capital Q, so write here small q. And also we don't have v, so here instead of dv just write dy, because there is no q and no v. So dz is equal to a du plus a square plus a into dy, and when integrating we get z to be equal to a into u plus a square plus a into y plus the constant b. And now putting back the value of u only, that is log of x. So z is equal to a log of x plus a square plus a into y plus the constant b is the required, I'm writing over here, complete integral, right? Okay, thank you.